All right, so for this one, we have a 5 kilogram block sliding on a frictionless surface, is moving with an initial velocity of 1 meter per second. The impulse that is applied to the block is shown in the graph. Oh, I need the graph. Uh, let me pull up the graph here. Where's the graph? Here. So let me get the graph too. Oh yeah, I did this one yesterday with the AP kids. Probably should have recorded the video then. All right. So that's the impulse graph. And so, what is the block speed at time 6 seconds? So a couple things I want to remind you guys of, that the impulse J is equal to the change in momentum and also equal to the force that's applied over time. Okay? So first of all, our momentum, our initial momentum is M1 V1 initial. And then we're going to add to it some extra stuff. Okay? And that's how you get the momentum. All right? Now this one is not that hard. But we'll figure it out. Okay? So first thing we want to do is figure out what is the impulse based on this. So it looks like our delta t, we go from 3 to 5. So delta t is equal to 2 seconds. And then the force that's applied, if you look at it over here, this is the force. So your force is equal to 8. So then our impulse J is equal to 8 newtons times 2 seconds. Okay? So our impulse is equal to 16 Newton seconds. Okay? But now remember, that's also equal to your change in momentum, right? So you could think of this as F delta T as equal to mv. So I can, if I want to find the velocity, the final velocity, because that's really what I need, what I can do is I just divide both by m, the mass. And so when I do that, I can get that the velocity of the object after, or the change in momentum, remember it's the change in momentum, that velocity is going to be increased from the impulse. Will you get that real quick? So that's equal to F delta T divided by the mass, or 16 Newton seconds divided by the mass, which is 5 kilograms, just that right there. Okay? And so that ends up becoming that our second velocity is equal to 3.2 meters per second. Okay? So now if you want to find the final velocity, it turns out we would do this a little differently. Our final velocity would be our initial velocity plus our increase in velocity. In other words, our initial velocity is 1 meter per second, and then plus the increase in velocity, right? So because this is technically delta P, delta momentum. So it's going to increase by 3.2 meters per second. So what's our final velocity? 4.2, yeah. I wrote down the wrong thing. Meters per second. Any questions? Okay. That's problem number 12.